All right. First off, you need to write this down if you don't already have it. For the empirical rule, 3 important characteristics. Standard deviation will have the following characteristics, as long as, remember, for the empirical rule, it has to be a bell-shaped curve and symmetrical on each side of the mean.
Should it be the third one, the third 3SD?
Yeah, it should. I don't know why it says 2, that last one. This one right here, you are absolutely right. This should be 3 standard deviations from mu, the mean. So 68% of the data lies within 1 standard deviation from the mean. That's that 34% in a negative direction, 34% in a positive direction. 95% of that data lies within 2 standard deviations. I should have used a different color, but whatever. That's from the mean all the way up to here. In a negative direction, from the mean all the way out to here in a positive direction. And then 97% of it lies within 3 standard deviations. In a sample of 200 high school girls, the mean height for the girls was 64.5 inches. U. Someone said U, we took their heights? Yes, we did. With a sample standard deviation of 2.6 inches. So the sample, lowercase s, standard deviation was 2.62. The average height was 64.5 inches. That's going to go right here, right down the middle. That is 64.5. Well, we're going to add and subtract that standard deviation to figure out where the other points on this bell-shaped curve are. It says the distribution was found to be symmetric and bell-shaped, which is why we're allowed to use the empirical rule for this example. 64.5 plus 2.62 is 61.12. And this is all in inches. I'll put that over here so I don't have to write it down. I thought I added it. It should be 67. I just didn't write it down right. 67. The 7 isn't writing. 67.12. Add another 2.62. I get 69.74. Add another 2.62. We get 72.36. Then I'm going to take that mean, mu, 64.5, and subtract 2.62. On the other side, that gives me 61.88. Take away 2.62 gives me 59.26. 61.88. 59.26. Take another 2.62 away from that, 56.64. $56.64. It asks us to estimate the percentage of girls whose heights are between 64.5 inches and 69.74 inches. So we're going to be looking at 64.5 inches and 69.74 inches. And so we have to remember that how much falls within 1 standard deviation? 68%. 68% divided by 2 is 34% for that first standard deviation away. 34%. Why is this not working? 34% plus, we have it going a second standard deviation. How much falls within 2 standard deviations? 95%, 95 divided by 2 is 47.5. Subtract 34. This is a 13.5% between here and here. Altogether, that's your 95 divided by 2, 47.5%. 34%. So remember, the 64 would have been half over here and half over here. This is 34. 95 minus 64 means another 13 this way and another 13.5 this way. Sorry, another 13.5 this way, another 13.5 this way. But we only want this side of it. So really, we want within 2 standard deviations, but only to the right. So not the full amount, because it's symmetrical, we can do the 95% divided by 2. We can do the 95% divided by 2. In the next example, it says the estimate the percentage of girls whose heights are between 59.26 inches and 69.5 inches. So I'm going to go back to the other graph, because I'll just write the numbers on it real quick. What were our numbers on the bottom of this? So wasn't it 64.5 here, right? 64.5 plus 2.62 is 67.12 plus 2.62, 69.74, 72.36. Is that what we had before? Those don't look right to me. Is that what we had on the other graph?
Yeah. Yeah.
Okay.
Yeah.
Over on this side, we have 61.88. So I'm just copying down the same numbers I have on the other graph. Minus 2.62, which is 59.26. We're on example 6. Minus 2.62 is 56.64. That's a 6.4. They're asking us to estimate the percentage of girls whose heights are between 59.26% or inches to 6 inches and between 69.5, 59.26 and 59.2, 69.25. Yes.
Up there it says 69.5.
Yours says 64.5?
Yeah.
Thank you. So this should be 64.5 right there. So if I look at that, that's going to go from here to here. How many standard deviations is that away going to the left? 2 standard deviations away. Because it's 2 standard, and is it the whole thing or just half of the graph? It's half. Why is it still doing this? It is half of 2 standard deviations away. Well, we know that 2 standard deviations, you guys said, if you looked at it, was 95%, right? So half of 95% is?
It's like 42.2. No, 47. 46.
47.5. Isn't that what we had on the last problem, too? Now, do you think I'm going to ask you the same question twice on a quiz or a test? No. No, I might ask you from here to here. Would you be able to figure that out? 64 divided by 2, wait, how much is within the first one? 68, right? No? Yeah, 34% right here. So I split up the first standard deviation in 2. This is 34% right here. If this whole thing right here is 47.5, we just calculated that over there, then if I asked you a question for these two, you'd put them together, and you would get 81.5% of the data falling between those values. Example 7, estimate the percentage of girls whose heights are between 61.88 and 69.74. That's what you guys actually have on your sheet, right?
Oh, correct.
61.88 and 69.74. I'm going to go back to the previous screen just so I don't have to write it all over again. And I want to erase some of this so we can see it a little more clearly. So we're on example 7 now, and it was 61.88 and 69.74. 61.88, 69.74. That's within 2 standard deviations to the right, which is half of 95%, because it only goes to the right, and only 1 standard deviation to the left, but it's half of it, so 64, half of 64.
So that's like 32, and then 45.
32 and
47.5.
32
Yeah.
on the left and 47.5 on the right.
Yeah.
So again, a total of 81.5%. Just adding this percentage to this percentage. And this is for example 7. Just it didn't show it on the, I went back to this graph. Give example 8 a try to see if you can draw the same graph, because it's still the same mean and the same standard deviation. What are you asking?
Based on the standard deviation, you get.
Oh, got it, yeah. I was cutting those percentages.
Depending on which
in half.
way,
64 and a half equals 34.
depending on which way it points, you might have to divide.
Really?
64.
Well, you can, but where it's folded makes it difficult because it folds it right on the board.
Are they the juniors?
You probably divided like that.
I divide 95 by 2.
Yeah, because one of them is only takes up this much space, right? That's two standard deviations. But this applies to the rule of 2 standard deviations.
Oh,
God.
Hey, Baba. Baba.
Bro, this is shit.
132.
What does example 8 ask us? What does example 8 ask us to find?
No.
The percent of girls, right?
Percent of girls between what and what?
59.6
What is it, 16.74? Thank you. So even though the slide says we're on example 6 and 7, we're actually on example 8. Example 8, because it has the exact same numbers at the bottom of the graph that I have up here. You can write them on your paper pretty quickly and easily.
I know, but like, what are those?
Yep, but I'm waiting because they're all possible.
Sorry, guys, I'm bad.
On example 8. On example 8. Guys, I'm recording and you're all just talking right through me. Thanks a lot. On example 8, the 59.26 is right here. Within 2 standard deviations. 2 standard deviations away, if I had it on both sides, is what percentage? 95%. But do I have it on both sides or just one?
Yes.
1. So I have, on this side, this is half of 2 standard deviations. But that's an S there, not a 5. Half of 2 standard deviations, but 2 standard deviations is 95%. So I have to do half of 95% for just that part, which we said was 47.5%. You could also get by looking at the graph on the very front where we defined the empirical rule, and it shows you the breakdown of the percentages, and just add these 2 first ones together. But it goes to 69.74. Going to 69.74 is over here. That's also 2 standard deviations. So I didn't even have to cut it in half, because I could have just said it goes 2 to the left, 2 to the right, so between here and here is 95% of the data.
You baited us.
I didn't mean to trick you.
Example 8, I think, is the last one for this, am I right?
Yeah.
And then it goes to Chebyshev's rule. Well, that's it for today's notes.
What?